Good morning, sir. This is group number 1046, and this is our presentation video. The topic of our project is real-time simulation and analysis of cyber attacks in a sandbox environment. So our project is mainly based upon many different types of cyber attacks that happen. And what we are trying to do is basically recreate them in a sandbox environment and be as close to real life as possible. Yeah. So this is our project. As I said, we are going to perform many various attacks and show like what are the prevention methods that we can apply in our systems and in our projects to prevent these cyber attacks. Okay, so we'll be performing a total of 5 different attacks using ethical hacking tools. Uh, and the document that we will create will contain all of these steps. Yeah, next slide. This is our uh, literature review. We have already talked about this, so we'll be skipping over this. Yeah, these are the gaps and demerits that we identified in all of these projects, in all of these literature survey papers. We can move ahead. Okay, so the existing system for vulnerability assessment basically is a manual system where an expert has to go through all of these vulnerabilities by himself, and this is very time consuming and takes a lot of like manpower and skill. So what we trying to do is automate this process, and basically our project will help us in automating all of this vulnerability assessment. Now I guess we can move directly to the attacks that we researched, and the first attack is brute force. So Aryan will be taking over now.
Good afternoon, sir. So brute force attack is basically just using whatever the user has entered and the password that he's entered, and repetitively analyzing what will the correct username and the password. So this is our main page where the user will enter his name and the password. Next one. So the request will be captured via burp suite. So burp suite is a web security testers toolkit, basically for some repetitive operation like capturing the username and the password. Burp suite is used so that, because it's a very repetitive process. So for example, there are hundreds and hundreds of requests. So burp suite will be able to capture them all. Finally, so we'll compare the user.txt and password.txt, whatever the user has entered in the user section and the password section, and one with a different entry in the length column will be the correct credential. Okay, so no, before this. Yeah, so there are several ways of preventing brute force attacks. First of all, there should be a lockout if many number of attempts are being failed, in case, because it is continuously asking for requests. Then obviously captcha is used by almost all websites nowadays because it is something that machines can't detect and only humans can do. So burp suite will not exactly work on this. And then limit logins similar to the first one, and OTP or secret key can be used to the whatever, to the user's mobile or something, so that he knows that something of this sort is happening. Now SQL injection.
Yeah, now I'll explain the SQL injection. So basically, SQL injection is a web security vulnerability that allows attacker to interface with the database that we are using. And so basically, by interfacing with the database, the attacker can get the user's personal information, which can contain important and crucial data like usernames, passwords, and email addresses. And so basically, SQL injection occurs because there is a no secure connection between front end and back end, and there is some vulnerability, and there is some API which is not properly endpoints are not properly made, and it can be manipulated. So yeah, this is the in display it is showing like we will be using DVWA to perform the SQL injection. So on writing SQL command like select all data from get all names, user will be able to get the names, and also in some cases on writing the ID and querying the password, attacker can get the password if the backend is not properly made. So now prevention of SQL injection. So SQL injection can be prevented by avoiding administrative privileges and setting the right privileges and authorizing only the right user, not giving the permission to all the users that are using the website, and don't connect database to the application with root access directly. Instead of giving root access, some administrative access should be done, and using a wire web application firewall to detect and block the SQL commands. Yeah, so these are the prevention. Now, yeah, next slide.
Yeah.
Hmm.
So I will be explaining XSS attack. So in an XSS attack, an attacker uses sorted XSS injection to inject malicious code into the user database. So often using JavaScript code. If there is no input validation, the malicious code is permanently sorted by the target application. For example, within the database, an attacker may enter the script, say such as from the comment field or through forms. So when a victim opens the affected web page in a web browser, the XSS attack payload is loaded in the victim's browser as part of the HTML code. This means that the victim will end up executing the malicious script once the page is loaded. So here, as is shown, this is a comment box. So was here the name is given as test, and the users put a malicious code, HTML code in the comment box. When the user signs it, there is a cookie generated which bypasses the system, and the user sensitive information is uh, vulnerable to the attacker. So the prevention method for excessive solid attack is the straightforward approach to avoid any HTML codes that can be added in the comment field. And the other prevention method of the same would be to check for any queries that can be written in the comment field, and to check for validation of various comments. So the next is excessive reflected attack. So so in the excessive reflected attack, the attacker's payload must be a part of the request that is sent to the web server. In this reflected, it is reflected in a way that HTTP response include the payload from the HTTP request. The attacker uses the malicious links, phishing mails, or other social engineering techniques to lure the victim into making such requests. The reflected SSS is a prevention is a precision attack. So the attacker needs to deliver the payload to each victim. These attacks are often made using social media. So in here, the attacker changes the URL and puts a query in the URL, where using this query, the attacker can generate a cookie which can reveal the database of the user. The next thing, which is the excessive reflected attack, uh, uh, DOM attack, which we are going to implement, is the DOM-based XSS is an advanced XSS attack. It is possible if the web page application client-side script writes data provided by the user to the document object model. The data is subsequently read from the DOM by the web application and outputted to the browser. If the data is incorrectly handled, an attacker can inject a payload which will be sorted as a part of the DOM and executed when the data is read back from the DOM. The DOM accesses attack is often client-side attack, and malicious payload is never sent to the server. This makes it even more difficult to detect the web application firewall. So we have shown the implementation of how it's going to happen. To the prevention method of excessive DOM attack is filtering any input arrival which is there, and encode the data on the output, which means that at the point when the user controllable data is the output in the HTTP response, they encode the output to prevent it from repeating as the active content. So this is the way which excessive attack can be prevented. Next attack can be followed by my teammate.
Okay, so I'll be explaining the CSP bypass attack. So CSP basically means content security policy. So as these are a set of rules that are defined by the server, by the developer on a web page, and they are mainly present to prevent XSS attacks, which Shubham already talked about. So as you can see in this screenshot, there is a content security policy header in the response, which says script src self unsafe inline and nonce this. So this basically tells the browser that only scripts that are present on this server only should be loaded onto this web page, or a script with a property of nonce tmv dash dash dash. So let's go to the next slide. Yeah. So to load an external script, which is basically debarred from being loaded on this web page by the developer, we can just add a property named nonce is equals to that value that we found in the header, and use this to load that script. So what this did was basically loaded a script which was not allowed by the developer onto this web page. So this basically bypassed the security rules that the developer had set, and an XSS attack was successful. So basically, bypassing this CSP is as easy as checking the response headers and finding out what scripts are allowed to be loaded onto a web page. Next slide. Okay, so for the prevention, this can be prevented by using a strict CSP, and by only letting the browser load scripts which are present on the website itself, and also by trying to minimize the get requests possible from other servers apart from our own, and all of these requests should be filtered on the front end. Okay, the next will be taken by Ujjwal.
So, sir, the next attack is insecure captcha. Captcha is completely automated public during test to tell computers and humans apart. Example like Google reCAPTCHA. Captchas are usually used to prevent robots to make an action instead of humans. It helps prevent brute force attacks. If CAPTCHA are badly configured, it could lead to unauthorized access. Here we will first download the tamper packet extension tool for tampering packet data sent to the CAPTCHA and enable the same. Then we will fill in the password and confirm the password fields. Then we will press the submit button. Tamper packet extension will capture all the packet information our request sends and will display the same in the form of a pop-up. Change the step and upgrade insecure options to 2 instead of 1. So we have successfully bypassed the capture. Next slide. Prevention of insecure capture. We can prevent the insecure capture by not allowing to submit before captcha is filled and trying to use just different type of captchas for a website. Next.
Okay, so I will conclude now. So in this project, we went through 5 different types of attacks and wrote down the prevention methods. So what our project did was recreate these attacks and added the prevention methods as well. So in the future, if any project is going to implement some web security features like we talked about in this, we should always use these policies, use these prevention methods that we displayed here. And yeah, basically that was our project. Thank you. That was it.